Hi, Professor. I wanted to make this video to really show you what I have going on in this project instead of just telling you what it was in the paper I wrote. And plus, what I wrote in that paper, it's the same, but a little bit is different because I changed up some more stuff in order to get the animations working. But basically, I have this video divided into two parts. The first part's going to show you what I currently have accomplished right now on the project, and that's that I can control all the LEDs, or not all of them. I can control the LEDs individually and control their color as well. I also have the animation ability working, and then I have the tic-tac-toe game programmed on my phone. Um, all three of these goals that I set out, they're limited because I can currently only control 19 LEDs. But in the second part of this video, I'm going to show you what I'm doing to try to overcome this limitation and actually show you some of the code throughout the video, but at the end too, of why I don't have it quite working just right to control all the LEDs. But I think it is a viable solution to solve the whole problem and have the project completed. But I do think I have a lot of it completed. But enjoy. Let me know what you think. Okay, this is Android Studio. It's the IDE that I use to program the actual Android app in. You could see these three file names up here. Um, this is where all the functioning code goes. And each one of these files has a matching file that controls the layout. And um, you connect each I guess like each button will have an ID number which you could connect over here in order to access its functionality. It's kind of similar to a web page, but like you can see control activity up here. I have the control layout. So on the right over here, this is how you design the actual layout of the app, and there's actually a button down here where after you put the code in, you actually see what it's going to look like. So this is what my actual phone looks like when it's actually uploaded. But over here on the left, this is where the functioning code is at, and I'll run through some of it. But like this function right here to override fun, that controls all the button clicks basically. Um, for this one over here, this is a lot of repetitive code for each LED. But you can see over here LED 1, which matches the ID number. Let me see if I can find it. Right over here of LED 1. So it controls that button, and when you hit that button, it sets the background color to this RGB value. And this RGB value I'm getting from this color select activity. It's temporarily saving it and just transferring over, and it's saving it into the database right over here. This is what this little editor function's for. And I basically repeated that for every button over here. Further down, this long repetitive function I have over here, which is the clear button. I have it basically so when you hit it, it just sets everything to the default value. So that's a pretty good. It's pretty convenient, but it's pretty repetitive. But later on, I figured out how I could cut down on all the repetitiveness by making loops. But I wasn't able to figure it out for everything though. But I do use it on later on. So this is how you set the buttons, how they're actually able to you connect them like that. The up top show the functionality, but you have to do this before, so it actually knows what button it's talking to. Um, this is where it gets pretty interesting. These button on clicks, these are well, basically, let me see. Where's the getting lost in this? All right. Yeah, this one right over here. Actually, that's how I do the animation over here. But up top, This is one of the loops I made, so I wouldn't have to go through all of the code again and write it repetitively. I figured this out later. But this is how I'm putting together the whole string so I can actually send a string over to the Arduino and it's able to parse it. But yeah, it's there's a few all these commented lines out here, or this one right here. This was like an earlier one I tried to do, but I had to change it to make it work better. And then later on, this save one, this is what I used to in order to put together a different kind of string, and so it knows that it's going to be doing an animation. But other than that, a lot of the stuff, the color select activity, let me see, you can see it right over here. It's pretty interesting. I liked a lot of the stuff, especially over here on the control activity. There's a lot of built-in functions that you could use, like this one right over here, LED string drop last. There's a bunch of little neat things in Kotlin where instead of writing out something where you have to delete the end of a part of a string, you could use built-in functions that automatically take care of it for you. So Kotlin was really good because if I used Java instead, I'm pretty sure all this code may have been like 3, maybe 4 or 5 times larger than what it actually is. So now that I showed you a little bit of the code, let me show you, actually demonstrate how everything works. I just realized I actually just only showed you part of the code because the rest, the other part of the code is actually on the Arduino itself. So what you're looking at right here, this is the Arduino IDE, which is used to program the Arduino. But whenever you program an Arduino, there's always two functions. Sorry, there's the void setup, and then there's the void loop. The void setup is what initially runs to set up everything. So the serial.begin makes a connection that's to the LEDs. Actually, it's doing at a baud rate, which is this transfer speed of the data at 9600. That's the standard that everything is usually started at. You can make it faster or slower, but I just kept it at 9600. This BT.begins, that's what I'm using to connect to the Bluetooth, and yeah, everything else, the fast LED, that just sets up what I'm going to be using in these functions below. The void loop is code that it continuously runs basically in a loop, but this doesn't actually run in a loop because at the end of this data, I have new data equal to false, so it stops at one point. If I had it run in a loop, I'm pretty sure it would just maybe go on and off and flash really quick, but that's not what you're looking for, of course. But over here is where I received the data, and it's basically taking in the string and recognizing that it is a string and separating into parts and putting it into this array over here, this char array that I have. And further down, I'm parsing the data right here. This is where the meat and potatoes are, I guess, which you would say. But yeah, this is what controls all the functionality. Basically, I have it set up one way where it goes through, so you could turn them all on and off, and set the colors. It reads it to tell which LED is each color, and then right over here, if it sees this S character in the string, that it knows that, alright, once I get to this S color, I'm gonna turn on all the LEDs to what I have it set so far, and then it's gonna pause, and then it's gonna run right through the loop again and look for a new set of LED values, and then turn it on again. And right now I have it on it's either a 1 or 3 second delay, and I could change that into the Android app actually, so I could actually manually change the delay time, but I wanted to get it working first. But right now it's either a 1 or 3 second delay between each animation. And the amount of animations I could put in there, it's well, once I figured out I could store more LED values, it will be unlimited. But it's not just like 3 frames of animations. You could hit this save button, which adds another S on the end of the LED string, and add a bunch of different animations, which I think is pretty cool. And I think I said in the paper that this was written in C++, but it's actually C, which they look kind of similar, I guess, but it's kind of all the same almost. Once you start programming one thing, you realize what functions you can use. So this is actually written in C code, not C++. So now let's get to the fun part, and I'll show you actually all of what I have going on too, and the LED's actually working. Okay, let me try to angle this right. So there's the app right here. I think it's that device. Yeah, it's connected. Let me clear that. And I'm just gonna select a few colors. Do row 4 green. We'll do red. 4 red, and then just 4 blue. These are just basic colors, but you can make any kind of color based on the RGB values. And turn it on, and there it is. Actually, oh, there's only 3 blue. I'm sorry. You can see that. I thought it was 4, but there's only 3. And also, you could see that before there was a whole delay, but I fixed that by in the string I put like an end character in there, so it knows that it's not receiving data anymore, so to execute the program. So you hit off and on, it turns off nice and easy. But like I said, it's limited right now to only 19 LEDs. So yeah, but like I said, I'm working on it, and I may be able to finish it, but I'm just not exactly sure if I will be able to in time, because I'm working on something new that I haven't done before or even expected to have to do. But yeah, I just added a few more colors, that little pinkish color. So I think that's really cool that it's able to function like that. And let me show you the animations now. So I'm gonna clear that, turn it off. For the animations, you can see right over here. Let me see if I can see that. There's a save button. Before that, I had like 3 save buttons, and what I was gonna do was I was gonna save like 1 frame and save 1, then another frame and save 2, and then another frame and save 3, and then execute that. But I thought I just figured out a different way how to do it, where I could just have 1 save button and I could put as many saves as I want in there, so I could add as many animations as I want to, or as many frames as I want to. But let's see. I'll make just what I'm going to do, something real simple. I'm just going to make a red dot bounce down the line of the LEDs, of the LED string. So color, save this, and then clear it. Whoops. Color red. Save that. Clear this. Color red. Save that. Clear this. Color. And then I'm going to make it all red at the end, last one, the last animation. Hopefully I have enough memory to do this. Actually, there's a limit, like I said, because of the Arduino, how much data can be saved with the LED data. So I think it's going to work though, but we'll see. color and save this. And now the on button has two functionalities. It's just going to run it's because it's still sending a string over there, but this time it's going to be running the animation. So let's see. Yeah, there's a 3-second delay I put in for it. And you could put it's the same thing with just LED values. You could do more than one LED. You could do a whole bunch of different colors. I just did this one because it was really quick. I could do, but yeah. And then you have to hit the reset button to reset all these values. Well, let me show you now. I'll show you the game I have, but the game is not programmed to work with the LEDs yet because I was planning to having everything set up so I could actually see a grid and then program each value like on the board to an LED grid, but since I couldn't see a grid I didn't really even bother doing that, but I did program the game in here. So there's the game button on the bottom left. It just brings up tic-tac-toe and it fully works. If there's a win, it keeps score. You can see player 1 wins. If there's let me see if I could do a tie real quick. Whoops. Whoops, player 2 wins. I wasn't even paying attention. But let me see. Try not to have a win right here. That should do it. It says draw on the bottom and there's no win, and then you can basically just reset the score. But what I wanted to do is have it all, like I said, set up so I could see the layout, and then each button, like this X button, or actually what would first happen was as soon as you start the game, this whole board there'd be a function that just lights up the whole board to make it look like this on the blinds, and then each grid would correspond to not just one LED. It would be like a bunch of LEDs to make the actual pattern of the X, and then I would have the score up there by just having dots or individual LEDs, different colors maybe, just taking care of that. But right now I'm just going to show you what I'm currently working on right now. But you can take a closer look at this board because it's a lot different actually. Let me just maybe hard to see, but right over here, let me get a better look. There's actually, the original board is underneath this board. You can see it's kind of dark, but there's 2 layers right over here. You can see it better here. The first board's on the bottom, and then I bought this, it's called an Arduino shield. They probably make shields for all different kind of boards, but it basically just expands on this board, and you could like solder on it basically. I soldered in the back over here the power wires, these red ones. I didn't solder the chip. The chip is right in the middle over here. It's kind of hard to see. Right, my finger's right in the middle. I didn't solder that in because I just wanted to make sure I had it in right. But it actually works. I could send data to the chip and I could read it off the chip, but it's just not coming in the way I wanted to. And then I'm also having a problem where I'm getting stuck at 64 bytes, which is the size of the buffer of the Arduino. But that shouldn't matter because when you read the data off the buffer, it should restart every time it reads a character. It should empty that character and another one should be able to take its place. But for some reason right now, I'm stuck at 64 bytes. But let me show you a demonstration of this code working, which I don't have it programmed on my Android. I don't have it programmed on the Android app, but what I'm gonna do is I have the same or a different program on the Arduino, and I simulate the Android app by using my computer and sending a string over there using my computer instead of changing it up on the Android app right now. So let me show you that. We're back to the Arduino IDE. Yeah, this is what I'm working on right now to use the chip. And first, when I got the chip, I wired it up, and it took me a little while because you have to wire it up different ways depending on what you're trying to do with it. And I think I may actually be missing a part, a capacitor, and I ordered that off of Amazon, and it said it got delivered, but basically it didn't get delivered, and now they refunded me money. I'm actually getting another one shipped, a pack of 25, and I only need really one anyway. But that's in the mail. It should be here in a few more days. But I don't know if it's really something necessary, but I did read online that it could help stop data from flowing in when you want it to actually stop. It's called I think it's called a bypass capacitor. It's a regular capacitor, but the way it's used, they call it a bypass capacitor. But here's what I'm working with right now. I've been experimenting a lot with this chip. You can see all this commented out code. That's some of it's from the old other Arduino file I have that I was using for the LED string, but some of it's just different itinerations of what I've been experimenting with. But currently, I could show you what I have got done. This IDE is pretty cool because right over here at the top right, it's called a serial monitor, and it basically brings up a way where you could send data over to your Arduino, and then you actually could print it out to see what it's sending back. So I have it set up right now, so let me show you the code down here. It's right over here, it's receiving the data, and it's just receiving each char from the buffer, and it's putting each one of those chars in a memory address that's only 1 byte big that you can see right over here. And then after it receives it, I'm doing a test print just to print out the data from the chip, and it's basically just a small for loop to print out the data, and at the same time it's printing out the address so you could see the address it's on, which is equal to how many bytes it is actually too, because like I said, I'm only putting 1 byte in each address. So open up the serial monitor. You can just write something like test right here and send it. It says test. It's showing that it came through, and it repeated it back, sent it right back to me, and that it's 4 bytes long, which is true. You can see that its test is 4 bytes long. But if I write something bigger, like see, this stopped at 63. It's actually 64, the buffer. I think it may count something like an the end of the string has an end line character, so it may just not be counting that for whatever reason. But what I wrote in the top over here was a lot. It was more than this, what I wrote over here. But currently, right now, it's getting stuck at 63, and like I said, I'm not sure if the capacitor has anything to do with it. I don't think it does, but I'm still doing some more research to see if I can figure that out. But once I figure that out, I think all the LEDs will be able to light on, and because everything else is working. The code on the Android app, that works like it should, and then the parser, which I'm going to bring over and add to this Arduino code, that's going to work. I just got to make sure I could be able to save more than 63 bytes of data in the memory without it stopping like this. So now I'm just going to do a little conclusion wrap up. Basically, I hope I get a passing grade. because I didn't realize this project was going to be this difficult. At the same time, I think I learned a hell of a lot. And if I would have known that I needed this chip from the get-go, I think it would have gave me a little bit more time where I could actually get it done. I've been working a little nonstop, but there's also nothing to do right now with this quarantine. But yeah, I think I really did accomplish 90% of the goal. The only it's not, I guess, small part that I can't get done is this chip part, so I can actually control all the LEDs. And if I had that done, it would be working like I intended it to. But I just couldn't do it. Not because I was pressed for time, just because I wasn't anticipating it. And I don't know. I think this project was really interesting. And I hope you consider giving me a good, not a good grade, but at least a passing grade. And I hope everything is going good on your end, and stay happy and healthy out there. Thank you.